Hey everyone, in this video we're going to talk about something called the binomial theorem and how we can use that to expand um, binomials that are being taken to a higher power. Okay, but before we get too far into the binomial theorem, we got to discuss this thing called Pascal's triangle. So we're going to kind of flop back and forth, if you will. So famous triangle, and there's a picture of it, and this triangle actually goes on and on forever. You should be able to notice hopefully a pattern as we start talking about it. So notice at the top it starts with 1 and then it goes 1 1, then 1 2 1, 1 3 3 1, 1 4 6 4 1. We could keep going. What they're doing each time is these numbers, all right, add up to get you 2, right? 1 and 2 get you 3, 3. So you add your numbers to get your next row. And it always starts with 1, and then the next row would be 8, then 28, then 56, then 70, and 56, and 28, and 8, and 1. So it's 28, not 26. And like it can keep going on and on. So you might be thinking, well, that's super duper, but what does that do for me? Okay. Well, where these numbers come from, and what we're going to see here in just a minute, is these numbers end up being the coefficients of our terms when we expand binomials. So let's go back for a moment, talk about a binomial, right? Two terms. So there's either going to be a plus sign or a minus sign in between. So we're going to take generic two terms, A and B. We're just going to call it A plus B. Well, if we take that to the 0 power, well, anything to the 0 power is actually just 1, right? Doesn't matter what A and B are. Anything to the 0 power is 1. And well, A plus B to the first power, well, that's just going to be A plus B, or 1A plus 1B, right? Now, A plus B squared, okay, a lot of people make this mistake. I see it again and again. It's bad math. A plus B squared is not A squared plus B squared. That's terrible math. You can't distribute the squared, okay? A plus B times A plus B looks like this. All right, and you actually have to multiply it out. Okay, so we end up with A squared plus AB plus BA, but remember BA is the same as AB, plus B squared. So that gets us A squared plus 2AB plus B squared. And I want you to notice something, so I can put a coefficient right in front of these guys. Oops, I put it in the wrong spot. Right there is where it should be, in front of the B squared. Come on, behave, active smart board. Let's see, edit, undo. All right, edit, undo. There we go. Okay, so this should be a 1 in front of that B squared. So noticing our coefficients here, you should notice the beginning of Pascal's triangle. So 1, 1, 1, 1, 2, 1. Okay, so Pascal's triangle gives us those coefficients. All right, now the powers change. Like, so for instance, this 1, right, is really 1a to the 0 plus 1b to the 0. Or not plus 1b to the 0, that doesn't make any sense. But anyway, if there was an a to the 0 beside that, a to the 0 is 1, and 1 times 1 is 1. So we get 1 out, but this is a to the first and b to the first. Okay, well, this is a squared, and then it's a to the first, b to the first, and then it's b squared. So notice the a started at a square, went down to 1, and then went down to nothing. The b started as nothing, went to 1, now it's at 2. All right, now the reason we use what we're about to talk about, this whole binomial theorem and how we can expand it, is because, well, what if I gave you, the problem a plus b to the 5th? All right, well, a plus b squared is fairly simple, right? A plus b cubed wouldn't be too bad. I could take that trinomial that I just got from a plus b squared and multiply by a plus b. But when we get to a plus b to the fifth, do I really want to do all that? Not really. Okay, and that's where this binomial theorem comes in handy. All right, so if you look at this chart down here, all right, so the first top level, that's to the 0 power. All right, so these are all the expanded forms. This is to the first, second, third, fourth, fifth. And I don't actually have to memorize this. I just need to know Pascal's triangle, which is what the coefficients are. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. All right, those are my coefficients. And now back to what I was saying about the variables, right? So like we already talked about rows 1 or 0, 1, and 2. All right, so if we went to the third power, we could multiply that out and I could prove it to you. But notice it's going to be a cubed. b to the 0 is just 1, so that goes away, right? And then the next coefficient is 3 according to Pascal's triangle. A goes down a power to a squared, b comes up to b to the 1. Then a goes down another power, b comes up another power, a goes down completely, and b. Okay, so here is it in words, which are kind of confusing, but those numbers from Pascal's triangle, we can use those in the binomial theorem to know the numbers out front. Okay, so for every positive integer n, a plus b to the nth equals p sub 0 a to the nth plus p sub 1 a to the n minus 1 b plus p sub 2 a to the n minus 2 b squared. So you notice that a always starts off at that highest power and then goes down by 1 until it goes to 0. And then b starts at 0 and works its way up to that n power. All right, and then the p sub 0, 1, p sub n, those are those numbers from the nth row of Pascal's triangle. So those are just the order of the numbers. So we're going to do 2 examples of this. So x minus 5 to the 4th. All right, so let's go Pascal's triangle. So there's the 0 level, there's the 1 level, there's the 2nd level, there's the 3rd level, there's the 4th level. Well, once I get it written. And here is the, oh wait, no, I only had to go to the 4th level. Sorry, I was trying to go to the 5th level because I saw the x minus 5. All right, so we are going to use this level, right? So that tells us the numbers out in front. This is my a value, and this is my b value. Okay, all right. Also, the plus and the minus come into play here too, and we'll see that. So like you could really think of it as x plus a negative 5. So we're going to think of b as negative 5. All right, so here we go. Okay, so I know it's going to be 1a to the 4th, right? I'm just going to write it out in terms of a's and b's first, and I'm going to kind of plug stuff in. So 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus 1b to the 4th. All right. So 1 and then a to the 4th. So that's going to be x to the 4th. All right. And then 4, and then it's going to be x cubed, and then negative 5. And then it's going to be 6x squared, negative 5 squared, and then it's going to be 4x, and then negative 5 cubed, and then it's going to be 1 times negative 5 to the 4th. I put everything in parentheses even though I didn't need to, mainly because of the negative 5. So x to the 4th is x to the 4th times 1 is still x to the 4th. Okay, x cubed is x cubed, and then 4 times negative 5 is negative 20. So we're going to have minus 20x cubed. 6 times x squared is x squared. Negative 5 squared is actually 25. And 25 times 6 is 150. So it's going to be plus 150 x squared. Negative 5 cubed is negative 125, sorry. So negative 125 times 4 is negative 500, and that's x. And then negative 5 to the fourth, so 125 times 5, it's going to be 625 for that last bit. And that is expanded. And that's a lot nicer than having to multiply x minus 5 times x minus 5 times x minus 5 times x minus 5. Let's do one more. So this is a little bit more complicated, but this is my A and this is my B, and this time we're going to go to the fifth power. So 1, 1, 1, 1, 2, 1, so that's 0, 1, 2, 3, 4, 5. So this is my row. Okay, so I'm going to do just like what I did the last time, just because it helps me. You don't have to. So 1, and it's going to be A to the fifth, because it always starts with the highest power, plus 5A to the fourth, B, plus 10A cubed, B squared. Let's see, I'm doing that right. Sorry, I'm just double checking myself. It's late in the day. Plus 10A squared, B cubed, plus 5AB to the fourth, plus 1B to the fifth. Yep. So I almost ran out of room there. So I'm going to have to write a little bit smaller next time. All right, so 1 times 2x to the fifth plus 5 times 2x to the fourth times negative 3y plus 10 times 2x cubed negative 3y squared plus 10 2x squared negative 3y cubed plus 5, I'm running out of room, times 2x, and then we're also going to multiply by negative 3y to the fourth, and then we're still going to have, sorry, that jumped on me, undo, here we go. We're still going to have a plus 1, and then times negative 3y to the fifth. All right, here we go. Okay, I'm going to do these in green. So 2x to the fifth. So that's 2 to the fifth, or 32, x to the fifth, right? Because when it's a monomial, you're taking 2 to the fifth power and the x to the fifth power. All right. Then we've got 2x to the fourth. So 2 to the fourth is 16. And then I want to do the 16 times the 5 to get 80. X to the fourth. Whoops, and I forgot about the minus 3y. So I also want to multiply 80 times negative 3. So times negative 3, that's going to be negative 240. So here we go. We'll fix that. So take away this plus sign too. So it's going to be minus 240 x to the fourth y. All right, I won't make that mistake again. All right, so for the next one, we've got 2 cubed, that's 8. We've got negative 3 squared, that's 9. 9 times 8 is 72, and 72 times 10 is 720. So plus 720, and it's going to be x cubed and y squared. All right, the next one. 2 squared is 4, and negative 3 cubed is negative 27. So negative 27 times 4 is negative 108 times 10 is negative 1080. And that's going to be x squared y cubed. All right, then the next one, negative 3 to the fourth, that's going to be 81. 81 times 2 is 162, times 5 is 810. So 810, and that's going to be just a regular old x, y to the fourth. And then for the last bit, negative 3 to the fifth power. So that's going to be negative 405. So I'm going to erase this. So it's negative 405 y to the fifth. I think I did that right. 80. So let's see. 3 cubed is 27. And 3 to the fourth is 81. And 81 times 3, whoops, is 243, not 405. Silly goose. 243. I thought that number seemed off. But anyway, so that is your final expansion. So that's kind of the binomial theorem and expanding polynomials in a nutshell.